Hello, Dumelang, Sanbonani, Molueni, and a warm welcome to the Maths Genius video tutorial series brought to you by SABC Education. In these tutorials, we help you unleash the mathematical genius in you by showing you key mathematical concepts and how you can master them for success like a true genius.
Today we're going to be talking about prime factorization. So, as you can see, these are two words that need defining on their own. So, a prime is a number that is only two factors, one and itself. And then factor, when you're factorizing a number, you're expressing it as a multiple of what? As a product of its factors, right? So let's say factorize 4. All you're saying is express 4 as a product of its factors. Then we ask ourselves, what are the factors of 4? You have 2 and 2 and 1. So if you multiply 2 times 2 times 1, you're going to get 4. So basically what you've done is you have factorized 4 in this case, right? But now, if it's prime factorization, okay, let's do another example. Just factorize before going to prime factorization. Factorize a number like 120, for example, 120, right? So 120, I can write it as 60 times 2. I can write it as 30 times 4. I can write it as 15 times 8. You know, all this is factorization. But now, when it comes to prime factorization, you want to be able to use only prime numbers. Like in this case, this is not prime, this is not prime, this is not prime, this is not prime. So you find that we want to achieve a situation where you are only multiplying by prime factors. These are just factors, but you want to be specific and say that factor doesn't have factors of its own. You get it? So, what we're going to do now is prime factorization of 4, right? Prime factorization of 4, the easiest method to use here is something that you are familiar with, which you use in most schools, called the ladder method, right? The ladder method. Right, the ladder method. With the ladder method, what you simply do is you take your number that you want to factorize and then you use prime factors one at a time until you completely factorize this number. So let's try this. What is a prime number that can go into 4 without leaving a remainder? 2, right? So 2 is a prime number, because remember, it's not just factorization, but it's prime factorization. So 2 can go into 4, right? And it will be 2. So 2 times 2 will give us 4, like that. Then a prime number that can go into 2 without leaving a remainder is 2. 2 into 2 is 1. Therefore, we've actually factorized 4. How? Because 2 times 2 will be equal to 4, which we can even write as 4 is equal to 2 squared, right? Because it's multiplying itself twice, so that's where the squared came from. So we have done the prime factorization of 4. Unlike here, where we had 1, because 1 is not a prime number. Remember, condition to be a prime number, you gotta have 2 factors, 1 and yourself, of which 1 only has 1 for natural numbers, right? Now, let's look at 120. How do we do the prime factorization of 120? Okay, so it's prime factorization of 120, right? Like using the ladder method again, there's your 120. So remember the divisibility rules, right? Divisibility rules tell me that this number can be divided by 5. How do I know it? Because according to the divisibility rules, if the last digit is a 0 or a 5, then it's divisible by 5. So I'll divide by 5. Why am I dividing by 5? Because 5 is a prime number, and our goal is to express 120 as a product of its prime factors, and 5 is a prime factor. So 5 into 12 is 2, 4, right? 24. 5 times 24 will give you 120. Then, using the divisibility rules again, I know that 2 is a factor of 24 because the last digit is even, right? So I'm going to divide by 2, right? And it will give me 12. Again, the last digit is even. I know 2 can go into there. 2, and I get 6, right? What are the factors of 6 which are prime? There's 2 and 3. So I can use 2 or 3. I choose to use 2 again, right? It's by choice. I could have used 3, right? Because it's also prime. So 2 into 6 is 3. 3 into 3, 1. So what I've done now is that I have actually decomposed 120 into a product of its prime factors. So in other words, I can now write 120 as 120 is equal to 5 times, how many 2's do we have? 3? 1, 2, 3, and then times 3, which you can write as 5 times 2 to the power of 3 times 3. So what I've done is I have broken down 120 such that it is being represented as a product of its prime factors. And what are prime factors? They are those factors of 120 that only have 2 factors themselves, which is 1 and itself. So this is what we call prime factorization. You can do it for any number, no matter how big or small it is. You can express it as a product of its prime factors. Thank you very much.
Thank you for taking the time to watch this video. Unleash your mathematical genius today. If you have any maths questions, you can post them for free on www.mathsgenius.co.za or email them to info@mathsgenius.co.za.